Hey guys, today we're going to be looking at naming chemical compounds. So again, we're going to go through the same steps as we did last time. We're going to be looking at different ionic ones and then covalent as well. So first we'll start off with our basic binary ionic. So remember, binary just means two. Ionic means that the electrons are given or taken. And so if we're given something like this, all we have to do is look at what elements they are. So Na, if you look at your periodic table, is sodium. If you look at Cl though, that's chlorine. But we don't call it sodium chlorine. What happens is whenever we have a non-metal, we always change the ending to "ide." But only if it's the second one, which generally they are unless we're looking at an covalent compound. We'll get to that later. So NaCl is sodium chloride. This is two words, and it's just the basic ones. Let's do another one. So if we had Be 3P2. So for these ones, we don't really have to look at the numbers because when it's binary ionic, these guys are just our regular metals. We're not looking at multivalents yet. We only have two elements on here, so we're not looking at polyatomics. So Be, if you look at your periodic table, is beryllium. And what is P? It's phosphorus. But again, we don't call it phosphorus. When it's in a compound like this, we call it phosphide. So this becomes beryllium. And please note, I'm not using any capitals. I only use capitals when I'm writing the actual formulas down. I don't use them in the names. Phosphide. So beryllium phosphide. Okay, let's kick it up a notch. So let's see if we have polyatomic. So we know we have a polyatomic when we have more than two elements. In the examples above, we had beryllium and phosphide. Or phosphorus. Those are the only two things present. In these ones, it's going to be a little different. Well, in this one, we have NH4 and a Cl. So right away, we have three capitals, which means we have three elements, which means we must have a polyatomic. So now we have to look and we have to see, is our polyatomic H4Cl? Well, if you look at your polyatomic table, that doesn't exist. So it has to be NH4. Well, what is NH4? Well, it's ammonium. It's our only positive polyatomic. And then what is our Cl? Well, chlorine. But what do we call it? Call it chloride. So this is going to be ammonium chloride. Okay, let's try So again, I have three capitals here, capital K, capital P, capital O. Well, we need to figure out where our polyatomic is. Is it K2P? If you look at your polyatomics, that doesn't exist. It has to be PO4. Well, what is PO4? PO4 is phosphate. K is potassium. So this one, even though this is second, phosphate second, we don't actually change its name, because if we tried to change its name and wrote phosphide, well, that would just show as a P instead of a PO4. So we leave this the way it was written. So this will be potassium phosphate. And you have to be really careful with these, because if you look at your periodic table and your data booklet, we have phosphate, we have phosphite, we have phosphide. We have three different things that look very similar, and you have to be very, very careful with what ending you use, and you can't change it unless there's a reason for it. PO4 will always be phosphate. PO3 will always be phosphite. A P by itself will always be phosphide, unless it's at the beginning of a covalent, but like I said, we'll get into that later. Okay, well now, let's look at multivalent. This, I find, is the hardest. And the reason why is because you have to do math. Because you have to tell me which charge belongs to it. So remember, we did the formula writing, and we'd have in the name a Roman numeral that would tell us which charge. Well, now you have to figure out what charge it is. So if you're given something like Fe2O3, well, you see, Fe we know is iron. O is our oxygen, which in a compound we call oxide. But if you look at your periodic table, iron has two possible charges. It's either 2 plus or 3 plus. Well, in its name, we have to figure out which one it is. So if we look at the formula, we have 2 irons and 3 oxygen. Well, we don't know what charge iron has, but oxygen always has one specific charge. And what is that? Well, it's 2 negative. So if you look, we have 3 sets of this -2. So how many positives do we need to make it 0? Because remember, we always want to equal 0. Well, we need 6 positives to make a 0 pair. These 6 positives we need to split into 2 groups. So what happens when you split 6 into 2 groups? You're left with 3 positives. So that means the charge is 3 plus. I know this is a little confusing. We'll do a couple more. So it's iron, brackets, 3, oxide. So again, let's do another one, same elements, but different numbers. You are given FeO. Again, we know this is iron. We know this is oxide. Now we look at the charges. Oxide has to have a charge of -2. There's no other choice. It always has a charge of -2. We only have one of those, which means how many positives do we need? We need 2, because we have 2 negatives, we need 2 positives. Well, how many irons do we have? Just 1, which means both of these belong to that 1 iron, which means the charge has to be +2. So it's iron 2 oxide. Making a bit more sense? Okay, well, the last thing to look at is going to be at covalent. And remember, covalent, we used prefixes. So we used things in front of the names to tell us how many there are. So this one's really different. We don't look at the charges at all. We just look at how many there are. So if you're given something like CO2, well, we know the first one is carbon. We know the second one is oxygen. And again, the second one abides by the same rules as before. We need to call it oxide. And now we look at the numbers. There's only one carbon. When there's only one for the first one, we leave it alone. We just say carbon. But there's 2 oxygens. Well, what was 2 for our prefixes? Di. So CO2 is also called carbon dioxide. How about CO? Again, we have carbon and we have oxide, but there's only one of each. So we have carbon, and yes, we leave this blank when we leave before it blank when there's only one of them. But for the second one, we always have to put a prefix. And what's the prefix for 1? Mono. But we don't like having 2 O's side by side, so we call it monoxide instead of monooxide. So CO is carbon monoxide. If we had P2N3, P is phosphorus, N is nitrogen, but when it's the second element, we call it nitride. So let's look at how many we have. We have 2 phosphoruses. Well, the prefix for 2 was di, and because we have more than one, we have to put the prefix. So diphosphorus, 3 nitrogens, trinitride. Okay, well, that's it for the notes. Your assignment for today is to finish up the worksheet that you started last set of notes. So hopefully you started last week. It is only the 1-page assignment, so hopefully you're able to bust through it pretty quickly. I will be posting an answer key online on my Google Drive. I think I may have already, because I want you to be able to see where you've gone wrong. Hope you guys are doing well, and I'll talk to you later.